In 3a, you have to find the change in magnetic flux, which is the final flux minus initial flux, so the strength of the magnetic field times the final area minus strength of the magnetic field minus the initial area. The trick is you're given the area in centimetres squared, and this area needs to be in metres squared. Converting from centimetres to metres, you divide by 100. Converting from centimetres squared to metres squared, you divide by 100 squared. So 250 centimetres squared divided by 100 squared, which is 10,000, gives you 0.025 metres squared. So when you plug those values into the equation, the change in magnetic flux is the strength of the magnetic field minus the final area minus the strength of the magnetic field times the initial area. And so the change in magnetic field is, the change in magnetic flux is 1 by 10 to the negative 4 Webers. 3b, the average EMF is equal to the negative of the number of turns times the change in flux over the change in time. Change in flux we just worked out in part A. The number of turns you'll read in the question is 30, and so the change in time is 0.5 seconds. So by applying that rule, we see that we generated 6 millivolts. The sign doesn't really matter there because it's asked for the average. 4a, with the helicopter in the magnetic field, the flux again is the strength of the magnetic field times the area, and that strength of the magnetic field was up, so the magnetic field is perpendicular to the helicopter blades. So that's the strength of the magnetic field perpendicular to the area. The area swept out by the helicopter blades is equal to pi r squared, so pi times the radius of the blades squared. So that approximately equals 50 metres squared. And so the total flux is 2.5 by 10 to the negative 3 Webers. I hope that's helped.